Ladies and gentlemen, we're going to do some nomenclature from Fall 14, Test 1. Always start nomenclature questions at the end. Tridecane, 13 carbons. 2, 4, 6, 8, 10, 12, 13. We're going to put two groups on carbon 5. I'll start with the easy one, isopropyl. 1, 2, 3, 4, 5. Isopropyl on 5. And we get that down here. And there's this 1,1,2 tribromo isobutyl. Wow. What do you start by drawing? In the parentheses, always start with the end because that's the thing attached to carbon 5. Isobutyl. That's 3 in a row, which is one less than butyl, and then a V on the end to get to butyl. And we have a strategy for making sure we have an R stereocenter. You do your numbers. A C with a branch, a C that's next door to a branch, a C with a whole bunch of carbons after it, and a C with only 3 carbons after it. If you connect those, it's counterclockwise, and that would be an S stereocenter if the number 4 group was on a dash. Do we want an S stereocenter? So what are you going to put the 4 group on instead? Wedge. When this came up earlier in class, I said, can you imagine a stereocenter without an H group as the number 4 group? And yes, I can. It's right here. And then a dash on any adjacent position, right? You could go there or there. I'll go down here. Remember, I need a wedge, I need a dash, and I need them to be adjacent. That's for stereocenter. So really, I just need the picture there for your for the activity. Bicycles, I think, are the easiest thing in going this direction. You just start with the 2 dots and just go from there. We got a lot of room left to write, so let's use it. I need 7 carbons between the dots. That's what that 7 means in the parentheses. 7 carbons. 1, 2, 3, 4, 5, 6, 7. Then I need 6 carbons between the dots. 1, 2, 3, 4, 5, 6. And then I need 2 carbons between the dots. Go down here. 1, 2. Yeah. I didn't draw the who? Oh! I'm not having a good time reading today. And I think that changes our stereocenter. She correctly pointed out in our first one, we did not put the bromines on that group, did we? Totally forgot it. And that's going to change that group's priority too, I'm pretty sure. Oh, that's good we caught it now, right? So there's bromines on 1, 1, and 2. What is carbon number 1 of the isobutyl group? Remember, inside a parenthesis, these numbers refer to the group, the isobutyl group. Carbon 1 of the group is the one attached to the chain. You're going to put 2 bromines here and another one over here. We'll do that in purple. 2 bromines on 1, 1 on 2. And that, I think that switches our 1 and our 2, doesn't it? Which means our stereocenter is wrong. Wow. It's ignoring me. Okay. Carbon with a bromine is 1. Carbon without a bromine is 2 because it's got 2 carbons attached. I really wish I had a quick way to erase that wedge in the dash. It's a good reminder of our strategy. So we're back to here. Now the connection is already R and it needs to be R. So what kind of a bond are you going to put the number 4 on? A dash. I'm glad this gave us both examples for stereo centers. And adjacent wedge, I mean, why not this one? Please make sure it goes all the way. And thank you for paying attention. There you go. All right, now we got this Burger King thing down here, whatever you want to call that. You decide carbon 1, and that means this one's carbon 9. And I need to know where carbon 16 is. So after you go 1, 2, 8, 9, where do you have to put 10? There's no choices now. Is it to the middle or is it downward? We've done the ring on the top. You have to, that's the biggest ring. You have to do it first. Then number 10 is on the next biggest ring through the middle. 10, 11, 12, 13, 14, 15 is there. 16 has to be as close to 15 as possible, but you can't use 1. You can't ever count a carbon twice, so you got to go 16 down here. And there's 2 groups on 16. What are the groups on 16 called? Yeah, the group's not called tripropyl. There's propyls. There's 2 on 16 and a third one on 1. So make sure you draw 2 separate propyl groups on 16 and 1 on 1. And then on 9, what do you draw? A methyl group. And I'm not going to forget to finish this time. I've drawn the methyl. That's what you connect first. This methyl has how many chlorines on it? 2. Now, how's that different than, say, 9, 10 dichloromethyl? This is a separate example. Separate example. Because this gets students. These are different things. They have the same word, dichloromethyl, but this time the di doesn't mean there's 2 chlorines on a methyl. That means there's 2 identical groups. How do I know that? The di is preceded by 2 numbers. That di means 2 identical groups. The name of the group is chloromethyl. So whatever, 9, 10, whatever, you would have a chloromethyl on 9 and a chloromethyl on 10, as opposed to our example here, which is a dichloromethyl group. How did I know it was a dichloromethyl? There's only 1 number in front. That means there's a group on 9 and its full name is dichloromethyl. When you have 2 groups that are identical, the di means 2 groups that are identical, and it better be preceded by 2 numbers. Okay? So good, this came up like this. Now it's just about the stereo centers. We need to make sure 1 is R and so is 9. So tell me if I lose you here. A carbon with nothing but carbons is 1. A carbon that only has 2 more carbons is 4. A carbon with a bunch of carbons is going to beat a 4. It goes carbon 1, 2, 3, 4, 5, 6 times then a branch. The top one goes 1, 2, 3, 4, 5, 6, 7 times. So this carbon is being compared to this one, and clearly that's not as high a priority as that. That's why I put the 2 there, because it hits this faster than it hits the same carbon on the top. It needs to be R, and it currently is counterclockwise. What's your strategy to fix the stereo center when it doesn't give the right direction? This gives a counterclockwise, and it needs to be 4 on the wedge, she said. It's all over it. An adjacent bond for the dash, that is an adjacent bond. And then you start all over on carbon 9. You got a 1 for a carbon with chlorine. You got a 2 for a carbon that goes next to a branched carbon. You got a 3 for 6 Cs and then a branched carbon, as opposed to 4 for 7 Cs and then a branched carbon. This one's already clockwise. So what's your 4 going to be on this time? Wedge. Let's use baby blue again. Why not? No, dash. Sorry. Somebody said dash, and I changed their word for them. I don't know, psycho stuff going on here. If it gives the right result, 4's on a dash. If it gave the wrong result, 4's on a wedge. Don't forget the adjacent. I need a wedge and a dash for every stereo center. In a nomenclature question. And I think we got everything we need to for that lovely little 3-pointer. Got it. Okay. Stop it.